So hello guys, welcome back. This is Surendra and we are going to start multiplexer. So in last video we have done with carry look a header and I have left one topic called BCD header. I will cover in last because that is too small topic and multiplexer is totally different from that. So I don't want to mix them. So I will cover in last topic of combinational circuit. So in this video we are going to start with multiplexer. So the multiplexer is a combinational circuit which contains multiple input and single output. The based on selection line, the input are selected and transferred to the output. So like this is suppose multiplexer. So there is multiple inputs and single output, and there are some select line. So based on select line, this input is transferred to the output. So like 2 to the power n input and n selection line, and this is output. So this is input and this is output. So what I have said that multiplexer is the combinational circuit which contain multiple input, single output based on selection input. This is selection input. Selection input. Based on selection input, the input is transferred to the output. So if we have 2 to the power n input, so for that we would have n select line. So this is the multiplexer. So firstly we will start with, so if the value of n is 1, so we will start with 2 raised to 1 multiplexer. So it is also called mux. 2 raised to 1 mux. Raised to 1 mux. So in 2 raised to 1 mux, we know that the input will be 2 because 2 to the power n, 2, and select line will be 1. So here the input will be 2 and select line will be 1. So this is select line, this is input I node and I1, and this is output y. This is 2 raised to 1 mux. So for that we will make a truth table. Like if s is equal to 0, then the I node will be transferred to the output, and if s is equal to 1, then I1 will be transferred to the output. So this is I1. So then we have to write the equation. So the equation will be write in such manner that like y is equal to, where s is 0, so we will take s bar into I naught plus s into I1. So guys, if this like if the value of s is 0, so 0 here will be 0, so 0 into something will be 0, here 0 complement of 0 1, so output will be I naught. If s is equal to 1, so this 1 complement of 1 is 0, so this will become 0, and 1 into I1 will be I1. So when s is equal to 1, so the output will be y1. So this is the expression for 2 raised to 1 mux. So if we have to implement this one, so we will take here s and we will take one more input, not this is S bar. So we have to implement. First one is S bar into I naught. So this is input I naught, and second one is S into I1. So this is I1. Then these are added, so we can use or get. So this is the output for this one. So like if anybody said that how we will implement like with the help of NAND gate. So this is nothing but if you have to use a NAND gate, so applied double bar in this, and this is nothing but AND gate. So this is also can be implemented by AND gate. So mux always implement in form of SOP. So what is the meaning of SOP? Like this one, the product sum of product means product का sum, means product का sum. So this is means mux is always implement in SOP form. If you have POS form, then firstly convert into SOP form, then implement in mux. So then we will see the 4:1 mux, and then after that we will implement the higher order mux with the help of lower order mux. So guys, 4:1 mux. 4:1 mux. So in 4:1 mux, the value of n here, the value of n will be 2. So the input, how much input will be? This is input, this is input, this is output. So we will have 4 input, and we know that the value of n is 2. So we would have 2 select line and 1 output. N is nothing but the number of select line. So here the select line will be S0, S1. Don't remember this value. They will always give which one is MSB and which one is LSB. Don't remember this one. Sometimes many confused in this one, that which one is MSB, which one is LSB. Don't think that this is 0, then this is LSB or MSB. This is I0, I1, I2 and I3. This is Y. So guys, so when S0, here I have considered that S0 is MSB, S0 S1, and here output. When both are 0, then which one will select? I naught. When this is 0, this is 1, so this is LSB, so I1. This is when 1 0, this will be I2. When 1 1, this will be I3. So this will be the truth table for 4:1 mux. So just write in form of SOP. So y is equal to, both are 0, so we will apply bar. So S0 bar and S1 bar into I naught plus S0 bar into S1 and I1 plus S0 into S1 bar into I2 plus S0, S1 and I3. So this is the expression for 4:1 mux. Then we will implement it. Here we will have 2 lines. S0, S1, and then bar of each. This is not get, sorry. This is S bar. So firstly we have to implement this term. So this is both S1 and S0 bar. So this is S0 bar, this is S1 bar into I node plus. Then second term S0 bar. So here, from here we have taken S0 bar, and then S1, here S1, and then I1. So guys, you can implement similarly. So I have implemented this one. So you can see and implemented this one. Then we will move to toward the implementation of higher order mux using lower order mux. So the first question is to implement 4 raised to 1 mux using 2 raised to 1 mux. So guys, we have to implement the 4 raised to 1 mux using 2 raised to 1 mux. So firstly, what is the procedure? Like, we have to implement which one mux, then write over like upper, and then divide by which we have. So we have 2 raised to 1 mux, we have to implement 4 raised to 1 mux. So divide, so this will goes 2 times, and then divide 2 by again same which we have, so this will go 1 time, and then add these two, add, the result is 3. So we require 3 mux. This is the procedure to calculate the number of mux required to implement this mux, and we will see how we will implement, and you will definitely understand why this require 3 mux. So firstly like this one, I have one single mux. So this have one select line and 2 input and 1 output. So guys, we have required 3 mux. So I am saying that when we make the table of 4 raised to 1, so see, I'm just making table. So be like here some S1 and S2. So 0 0 0 1 1 0 1 1. So see that this one, this have only one two state. So for higher order we will write here. So like I have taken S1 as higher, or you can take anything. So I am taking S1 as higher, and then take S0, because before I have taken S0. So take S0 as higher, and then we will take S1 as lower. So we know that this one is this have only on two state. For every state this have two state. So by every input of this one we will connect one mux. This is I0, I1, I2, and I3. This is 0 1, this is S1, this is S1, so this is Y1, and this is Y2. So suppose we have made circuit on the basis of what I have said. But suppose if you have like a 0, as we know that if the like if both have 0, then it should select I0. So suppose this is MSB I have said that. So this, if this is 0, so this is 0, so this will goes to this one, and then S1, this is taken as 0 and S1. So when S1 is 0, when S1 is 0, we will select I1. So I1 will select to this one, and this one will select to this one. So I1 is directly transferred to Y. So we got, and then when S0 is 0 and S1 is 1, so this will select. So I1 will goes to output. So here I1 will go to output. Here when this one is 1, so this will go to here. When this one is 0, so I2 will go to here. So here is I2. And for when this is 1, so I3 will go to output. This is I3. So we have made similar truth table as we have made before this one. So this is similar truth table, and we have implemented by this one. So what we have done, firstly, what is we have to divide it by that one, and what we have to implement, to which we have to divide by what we have. Then what quotient come, again divide, and then again till then you are not getting 1, and then add all the quotient. You will got the number of mux required to implement that particular mux. So next we will see the 8 raised to 1 mux using 2 raised to 1 mux. The implementation of 8 raised to 1 mux using 2 raised to 1 mux. So guys, what is the procedure for implementation of 8 raised to 1 mux using 2 raised to 1 mux? So firstly, we have to implement this one. So we will write upper, and then we have to divide by 2. So this will be 4, and then again 4 divided by 2. This will be 2, and again 2 divided by 2. This will be 1, and add these all three. So this will be 7. So 7 mux required for to implement this one. So as we know that 2 raised to 3 is 8. So here the number of select line will be 3. So we have to just keep in mind that when you are implementing the higher order mux using lower order mux, in the rightmost will be the MSB, and then you would have another 2 mux, because we have only one 2 input for this one. So you would have another 2 mux, that will be second bit, and then you would have another 4 mux. Sorry for this, I'm not in, my drawing is not too good. Suppose this is S0, this is S1, and this is S2, and this will be I0, I1, I2, I3, I4, I5, I6, I7. So these all are 2 raised to 1 mux. So guys, I have implemented this one, and this should be the truth table as we have done the 4 raised to 1 mux and 2 raised to 1 mux. So we can similarly do for 8 raised to 1 mux. This will be the truth table for this one. So we will see that miss this is following, miss this table is satisfying or not. So firstly, when s is equal to 0, so this one will select. When s1 is equal to 0, so this one will select. When s2 is equal to 0, this one will select. When all three are 0, so I0 will select. So this is correct only. When 0 0 1, so I1 will select, this is correct. Similarly you can do for all other, all other will satisfy this one. So this is the procedure for implementing 8 raised to 1 mux using 2 raised to 1 mux. So the conclusion is that when we implement the multiplexer using 2 raised to 1 mux, we require 2 raised to power n minus 1 mux. We have seen that when we were implementing the 4 raised to 1 mux using 2 raised to 1 mux, so 2 raised to 1 using 2 raised to 1 mux, so n were 2, so 2 raised to 2 is 4, 4 minus 1 is 3, so we require 3 mux. And here we require 2 to the power 3, 8 minus 1 is 7, we require 7 mux, 4 2 1. So this is the required mux when we implement using 2 raised to 1 mux. And I will solve one more problem, then rest you have to solve. So guys, I am implementing the 8 raised to 1 mux using 4 raised to 1. So this is the task for us. So just see that divide 8 by 4, so this will be 2, and divide 2 by 4, so we know that this is not completely divisible, this will go one time. So what is the meaning, why this is not completely divisible? This is saying that the 1 mux will not use all the inputs, we would have to use only two inputs. If here is 4, then that is completely divisible. That means that we are using all the 4 inputs. Here we have only 2, so here we will use the which 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 mux is used for MSB, we will use only 2 input of that one. So this is the meaning if any mux is not completely divisible when we are dividing. So here we will use 3 mux. So this is 1, this is 2, and this is 3. We understand that what is the how we have to implement, and what is the main function, main M, and how we have to go through that one. But why I have taken this example to discuss this point. There is nothing anything you can do by own, I2 I3, and so guys, here we have like I have implemented this one. When this will 0, and here this will be to select line, sorry, S0 S1 and S2 S3, and here will be S2 S3, sorry for that one. So here when this will be 0 0, so this one will select, and then this should be 0 0, so I0 will select. So like S0 S1 S2, this is MSB, and this is LSB, S3, S3. So this is 0 0. When these two are 0, so this will select, and then when these two are 0, so I0 will select. So like that you can do by own. In here like here, sorry, you can do by own, like here I4 I5 I6 I7. So I have given the same nomenclature, that is not problem. You can do whatever you want, and here you can use from here also, from here also. That means whatever, just that will change that when the input will connect. Like suppose if you have given here, so when this one will get, when this is the 1 1, when this is the 1 1, and then this is 0 0, so this one will get. When this is 0 1, when this, then this one will get. So here you can like adjust how, when you have to transfer this input to here. So this is the main motto to teach you that when when we don't have completely divisible, then these two input will remain, and then you can configure according to you how you want to use it. So thank you for watching the video. In the last, if you have any doubt in whole video, you can comment, and in the last I go little faster. So if you don't understand, then please say, I will again say to